Good morning, good afternoon, everybody. Welcome to our Friday HSM Hangout. My name is Jordan Roberts, Product Specialist for Autodesk CAM Solutions. I am so excited today because we've got one of our top-notch application engineers, Tim Paul. You guys might have seen him on Instagram. We're going to be covering the Renishaw probe inside of HSM technology. Before we get started, just a couple of really quick housekeeping items. We always want to understand the background of the crowd. So here we go. We're going to launch this poll. We want to understand what kind of machines everybody's using today. Are you guys on Haas, DMG, Bridgeport? Get your votes in. This is a democracy, so every vote counts. Wow, you guys are really voting fast. This is awesome. Keep going, keep going, keep going. All right. Polls are closed. Tim, any thoughts as to what the outcome might be?
Have to go with Haas. They're number one in our country, right? So.
Yep, no surprise there. 62% Haas. That's awesome, guys. Thank you for that. We want to understand how long everyone's been using Autodesk CAM products. HSM specifically, as you might know, Autodesk owns the Dell CAM group as well, and there's a lot of great products there. We're focused on the HSM as that team that supports that product line. So get your votes in. Let us know. Awesome. Thank you, everyone. Look at that. This is great. This just really shows that these weekly hangouts are working and they're helping people get their jobs done. One more. I want to understand, for those of you that aren't using HSM, what software are you using? This is one of my favorite ones to ask because what we've seen is more and more people join these every week that are answering that they're using Inventor HSM and HSM Works, which is great. The workflow is undeniably the best in the industry. Let's close the poll. And look at that. 68%, Tim. That's phenomenal.
That's awesome. That was great.
So we got a good crowd here today of, HSM users. I'm sure as we go through the registrants, we're going to see some familiar names. This is a live Q&A as well, so as you guys have any questions for Tim, please submit those. Let us know who you are. Give shout-outs to your company. Feel free to include links to your Instagram accounts as well in the chat. We'll do shout-outs to you guys as well. So Tim, no more further ado. Thank you so much for joining us today. What do you got?
All right, so as Jordan said, I'm Tim Paul from the Autodesk team. Today I just wanted to show you our current probing functionality in Inventor HSM. It's a new functionality that right now is only in Inventor HSM, but we're working on adding it to Fusion and HSM Works. So if you're a Fusion or HSM Works customer or user, there should still be plenty of good information as it becomes available. So let's get over. We're going to go through just a quick couple slides. There we go. So a quick background on me. I started life as a mountain bike mechanic, World Cup mountain bike mechanic for one of the top women in the industry. And that's where I was exposed to modern manufacturing. And once I fell in love with manufacturing, I left the bike industry, just dove headfirst into manufacturing since then. My career has taken me on a pretty interesting journey through job shops, motorsports, aerospace, and I ended up landing at L3 Communications to start and run a machine shop for them. And that's when I became a customer for HSM Works. So since then, about a year and a half ago, I left what I thought was my dream job at L3 to change the industry with the Autodesk team with HSM. So if you are an Instagrammer, come check out what I'm doing on Instagram. One Air Tim is my Instagram name. If we meet someday, you'll probably understand why. But I get to see a lot of cool stuff, and some of it I get to share. And if you're not an Instagrammer, come check it out. There's a pretty neat machinist community there that it's interesting what's happening over there. So One Air Tim on Instagram. To speed this up and get to work, our agenda today is basically give you an overview of our current probing functionality. We have a part that would normally be a 5-operation part on a 3-axis mill. We're going to show you how I would do that, how I have done it in the past, and how I would do that with basically only 2 manual work coordinate system setups. So if we have time, we'll talk about the future a little bit, and if we have even more time, I'll kind of show you some hacks for how I would do, with our current workflow, how I'd do some in-process inspections on a Haas machine. So with that said, let's get over to the cam here. So a quick overview of the part. This is a simple part. I wasn't here to dazzle you guys with my CAD or toolpath skills. But what I wanted to show you was, let's get over to the model space here and turn on our fixtures. You know, this is a basic part, but in machining, the devil's always in the details. So I assume at this point, if you're on the webinar, most people could knock this part out pretty quick, but the dimensions and the tolerances are the details here. So what we have here is some Mighty Bite Talon vices that are going to hold it for a first operation. And then we're going to machine it from this perspective. And these through holes here have a pretty tight tolerance. You can fill in the blank for the tolerance for what is tight to you. Let's say we had a plus or minus 1 tolerance here, but the outside of the housing has something like a plus or minus 10 thousandths. My hope today is really kind of just show you a workflow, not really tell you how to make parts, but share a workflow that I've used successfully. Hopefully you'll get 1 or 2 things out of this. So if we looked at this part and said the outside of the housing could have a plus or minus 10 or 20 or whatever you would consider a loose tolerance, I see a lot of people waste a lot of time or spend a lot of time keeping the outside of a housing like this super tight tolerance, because they know that's how they're going to index the part through the rest of the machining process. Because let's say these side holes had a super tight tolerance to the sides here or something like that. So I'll walk you through that, but then we're going to flip-flop the part around and show you how we do some of the probing. So let's get back over to this cam space. And actually I'm going to turn off on the model. I'm going to turn off the visibility. So what I did here in the model space is I just have some fixtures that I can turn the visibility off for this whole folder and turn it on for another operation. So I'm not here to show you about the CAD, but in Inventor, this is something I use pretty often, is I'll turn on the visibility of one setup, turn it off for another. Some people will model up their whole table or whole vise, which is great. My focus is just to get a good representation of what I'm worried about touching. So let's go over to our first operation. So I pre-programmed this, and we're going to go through a new setup for the first operation. I'll show you what we did inside this operation and how to work through it, and then we'll go from there. So we're going to make this our default folder. So if you don't know how to do that with your keyboard, you'd hit Shift D and then come up here and hit Shift D to make this our active folder. So let's actually start off with a new setup. So what we're going to do is we're going to replicate this setup here, which is going to start with a probe of the X and Y, and then kind of work through some toolpaths. So for now, let's just do a new operation. A new setup. So we have a new setup here. First thing I would do, knowing there's a bunch of hidden assemblies, and I want to make sure that the only thing I'm grabbing is just the part I want to machine. So I'm going to cut it off, or clear the selection, reselect the model. Normally from here I would set up my work coordinate system, but for this I already have a solid set up for my stock. I'll explain why in a minute. But I'm going to jump back over to model. I'm going to open my first operation folder and grab the stock from there. So now we'll go back to the cam, and now it's time to set up our work coordinate system. So what I'm going to do is I'm going to grab the stem of the z-axis. I'm going to make it normal to one of the Z surfaces. And then I want my X, my work coordinate system is going to be down in this lower left corner, so I want to click on the X there and flip it around. So now I want to move it, so I'm going to hover over the little ball here and just click it right there. So we're almost done with the setup. So now we want to go to the Post tab. This is where I would name, give it a program number, and this is where I would call it something like first op. So today we're going to be talking about just probing with work coordinate system shifting. So for now we're going to leave the work coordinate offset and the override at the same. If we have time later, we can talk about how you might use this, but this also might be changing. So for the most part, you're going to leave these the same. So our job's ready to set up. Let's just drag this down so we can just work on it down there. So the first thing we did here was do the probe there and there. So what I want to do is go back to the model space and turn on this folder, the visibility of all the parts. Sorry. So we can come back over to the CAM tab. So the first thing I want to do is an X and Y, what I call a web probe. So I'm going to right click here and go New Operation, Probing, and Work Coordinate System Probe. So we could definitely pick different surfaces, but we could also just pick the top surface of our stock, and it'll automatically probe basically a boss or a square boss or an X and Y web. So the first thing I see here that I don't like is that my rapid down to plane is pretty low. And kind of good habit, in my opinion, is that your clearance height, which is the height that it rapids to before it turns on to what I call a safe move. I think Renishaw calls it a protected positioning or something like that. I like to set this to something that's bigger than my probe height. So now it's going to turn on, everything below this height is going to be in a safe move. So anything that touches the stylus, if it's not anticipated, so if I had a big bolt up here and it came down and touched it, as long as it touched the stylus and triggered the probe, it would stop safely. So we could definitely move, we can just drag around the bottom height. So let's say we wanted to probe our stock in the middle instead of up at the top. We can do that. So that's our first probe location right there. So what that's going to do is if I cut my stock maybe a little bit bigger than what my intention was, instead of, if I left the work coordinate system located there, instead of machining around it and having a heavy cut over here and a normal or light cut over here, this is going to shift it. It's not going to move my work coordinate system, but it's going to shift it. So if I had a 100 thou extra material there, or 10 thou, it's going to take half of it and shift it over, so you're going to have an even cut on both sides. Okay, so then the next thing I did was an adaptive facing operation there. We did an adaptive, 3D adaptive to machine the inside and outside for rough. And then we finished these pockets and finished the outside with a 2D contour. And then we went and finished the walls and floors of these pockets, finished the tops of these resonator tubes. And then also, if you look, I finished the top of the part. Now the reason I did that with the same tool is I did leave a stock to leave on this toolpath. And I finished the top here because I know later these holes here have a very tight positional tolerance to this floor. But I can't probe that floor from this angle, but I can probe this surface here. So if I machine this floor and this top shelf with the same tool, I'll be able to pretty accurately locate those holes on that direction there. So the first operation is done. I mean, we can copy these tool paths and dump them in here if we wanted. You guys don't need me to show you tool paths by this point. There's this hack folder here. If we have time at the end, I'm gonna show you some cool stuff that are kind of hacks for now, but they're still a pretty good workflow that I've used for years. So it pretty much summarizes the first operation. So that's how you would use a stock. Something that's kind of important to note in our development builds. I'm going to write down to talk about development builds when we're done. because we just released a development build that in beta mode will have some stock probing functionality. It's still in beta, so it actually has a couple bugs to work out, but keep an eye on probing. In your options, you'll be able to do a stock probing. Okay, so let's move on. I'm going to delete this folder here. Okay, so we're going to move on to the second operation. So I'm going to go to the Model tab and hide the, I'm not sure what I clicked there. Okay, get a little jumpy, so I'm going to hide the visibility of this. I'm going to show the visibility of my second operation, JAWS. So this is my work setup for the second operation. So the important thing to notice is on that first operation, I never really moved that G54 location. If when I managed the L3 shop, Andy and I always had this one vise set up with those jaws on there. We had a Chick 1 lock so we could change the vices, but when the talons were on there, G54 never moved. I never reprobed it. I just kind of moved it around the way I just showed you. But on my second job, or my second vise, I've got these jaws. So if you can see by my note, my XY0 is going to be on this surface here, and it's going to be against the stop. And then my Z surface is going to be on that parallel surface that indexes the part. So by doing that, we can finish the other 4 operations on this part without having to do a manual work coordinate setup each time. So I put the jaws in, and on a Haas machine, I would use whips or whatever, however you locate your part. I would set up my work coordinate system to be that lower left corner, and I wouldn't change for the rest of my programming. So if you click on the setup, you can see I have that work coordinate system there. But to get into the machining side of this, first thing I'd do is a facing operation there. And then my engineer was rushed, so he didn't have much time to put much thought into the GD&T, so he made this counterbore some kind of ridiculous tolerance to this to the center of this through hole. And if you look at the first operation, I probably should have simulated it, but I'll simulate it in a little bit. This through hole I machined really just a little bit past this surface. So this hole wasn't exposed until I faced off the that top carrier material. So now that this through hole is exposed, now I want to come in and probe it. Here, the first thing I do is a Z probe because the Z depth of this pocket is super important. So the next thing I did was probe that hole. So let's show you how I would Z probe this. So I'm going to switch over to make this my default folder. So I left click it, hold shift and D. So now anything I add is going to add to the second operation. I'll show you how easy it is to add a Z probe. So we'll just go here, click that top surface, and it'll probe right here. In the future, there'll probably be functionality to drag that around or add multiple Z strike locations. But for now, it's just going to put it in a good spot. So that's how I'd set up the Z probe. So we'll delete that because it's already done. But then the next thing I need to do is shift my coordinate to where I'm definitely cutting concentric to this. So this talks about our outside housing tolerance again. So again, the print says the engineer had some foresight and gave me a big tolerance for the outside because he doesn't really care about the outside. He just cares about all the guts. So what he really cares about is that this counterbore is super concentric to this through hole. So knowing that and the way he dimensioned it, I'm going to come in here, I'm going to machine it off and expose that hole, and I'm going to do a bore probe. So I'll show you how to do that now. So we'll right click here, new operation, and probing. Now, these are also available up here. I've got a habit of doing everything through the right click menu. So I'll automatically grab my probe because that was the last thing, and it might actually grab it just because it's a probing operation. So the next thing I do is grab that geometry, and you can see how you don't get a preview of any toolpath. So the reason for that is this hole, I believe, is about a ½ inch. My probe is 236 thousandths. So my clearance, which is the clearance between the probe and the wall, if you add the clearance and the probe up, it just can't fit in there, so it doesn't give you a probe preview. So if I make that something smaller, say 100 thousandths, you can see it gives you a preview. It actually gives you a preview to also avoid an island. So if we go to this probe type, it gives you different options that you have based on the input that you've given it. So let's do a XY circular hole, because we're not trying to avoid an island. It can go in there and just bang around. So the over traveled distance is going to be, I'm going to give you a resource here in a few minutes about where you can learn more about what all these features do from the Renishaw manual. But for right now, the over traveled distance is the distance it's willing to go past what it thinks that hole size is. So 400 thousandths is quite a bit, but that's a general Renishaw default, I believe. It's right around 10 millimeters. So for now, we have that, and we can definitely go in and change the heights to probe at a different location. So again, this top height is where you start moving in a safe mode. And then the bottom height, the other important height, is the bottom height, and that's where the strike point's going to be. So we'll hit OK. So now you have a bore probe. So the important thing to know there is, like I said, if we use the 10 thou, say we were positive 10 thou on the outside of this housing, then that hole is going to be shifted 5 thou if my math is right. So if we came in here and used that original location here, our concentricity is going to have an issue. So what this does is it's just going to shift it to where now when you go to machine this tool operation, it's going to be as accurate, the concentricity is going to be as accurate as you set up your probe and as accurate as your machine is. There's a whole nother conversation about the validity, I guess, of doing your own inspections on the machine that cut the part, but if we have time, we can talk about that later. So as you can see here, I probed this. I bored the pocket, and I spot drilled, and tapped, of course using the template I already had set up. And then I did some chamfering there and there. You might ask why I didn't do that for both of these. Realistically, just probing this hole would probably have given me a very accurate alignment to both of these, but if for whatever reason I had a chip or something, I saw the print and the engineer wants it dead concentric to that hole. So what I did, instead of doing all these however many tool paths, instead of repeating them again below that, which would have been a totally valid way of doing it, you could have copied and pasted, you could have done a couple things, is I highlighted all of them, and then I right-clicked on them, and then did add new pattern. And then I got this pattern folder here. So I kind of give you an idea of what we did in the pattern folder. There's a couple details that are important. Is I did a duplication pattern, and that brought up this. So I picked the source, so I picked this edge, because that's the source of where I want all my toolpaths to be patterned. And I picked the target, so I picked the same edge over here, and just patterned everything over. So the important thing to know is the default for this pattern is going to be order by tool. I think it's a good default because usually your intent is to save tool changes, right? So it's gonna do all this tool, do it here, everything it can without doing an operation ahead of itself that's going to kind of kill it. Everything it can, it'll sort the tools. My intent is to preserve the order because I want it to probe, bore, spot drill, and so on, and then come over here and do it again. Probe, spot drill, do all that. So it's an important little detail there. But now when I click on that pattern, it shows you the toolpath on both of them. So we'll shrink that folder and then see what else I was doing here. Okay, so the next thing I did was I had to chamfer the outside of this. So I know a lot of guys on this call make what I would call cosmetic parts, but even if it's not a cosmetic part, let's say the engineer said he wanted a 5 thou chamfer around this edge, But remember, it gave me a 10 thousandths tolerance on the outside of that, and I like to use all my tolerance. So if this was 10 thou bigger and the whole part was shifted over by 5 thou, you'd get a little chamfer here, a big chamfer there. So what I did was I probed the X and then I probed the Y. So I brought this up because if we do a new probing operation, if we pick that that surface, it has other features, so it's not as intelligent as it was on that other when I did the stock. The stock had no other features, so it snapped to the outside. So here you want to pick this surface, you want to pick this surface. It's smart enough to jump in between. You can adjust the heights if you wanted, and you would hit OK. My workflow would be to take that, left-click it, hit Control-D to duplicate. Any of those little shortcuts are all listed on this side here. So I duplicate it by hit Control-D. So I basically want that exact same toolpath, but I want it here and here. So I wanted a Y. Oops, I deselected that. So I want a Y web probe. So I hit OK. So that's how I got those two. And then what I did after that was a chamfer around there. So my chamfer should be very accurate to the center of the outside feature. So let's delete this. And now we're ready for the third. Now we're ready for the third operation. So you can see I didn't have to manually probe when I was setting up the machine. I didn't have to manually probe anything after that first setup. So now when we move back to the third operation, my mouse is jumping around, hit Shift-D, make this our default folder, and we'll expand it. And then let's go over to the model, and I'll show you how I did that. So on the model, I'm going to turn off the visibility for this. I'm going to turn off the visibility for this. I'm going to turn on the visibility for this. So now you can see how I'm holding it here. So let's go back over to the cam. And I don't need to walk you through the toolpaths on this, but I do want to talk about kind of how I set it up and why I set it up the way I set it up. So the first thing I did was, if you look at the print, this is set up based on these two features are center line on this. So what I did, so I did a new probing operation, and I wanted to just hit it here and here. So that's going to probe it and shift it. Anything this is off, it's going to shift it to where now it's machining to the center of that. So the other thing that's important that I mentioned earlier was that the engineer dimensioned these with a true position to this floor. I don't have any way to probe that right now. So the way I machined this surface here was very tightly toleranced to the floor. I used the same tool, same operation. It's basically as accurate as your tooling and as accurate as your machine's going to be. So what I did here was I probed the Y surface, and I'll show you how to do that. So new operation, work coordinate system probe, and I clicked here. So that's when it's going to come in and it's going to strike that surface there. So it's probably important to note that if you go simulate, you can click on that little thing there and it'll show you where it's going to strike. Now, it might look odd because it's below this edge, but I don't know if you noticed, I didn't machine that pocket on the first operation. That's something we'll be doing here in a second. If I wanted, I could definitely go to heights, and I could drag the height around. I could raise it up or down a little bit if I wanted. But for now, I know it's good, so I'm going to leave it alone. So we'll delete that to remove the clutter. And the last thing I did was a Z probe. So of course the engineer wants this to be, from this surface, wants this to be plus or minus nothing basically. And remember, I used the whole tolerance, the plus 10 thousandths here, so if I left my work coordinate system there without shifting it, it would have messed me up. So same thing, I'll do it again. Just do new probing, and I just pick that surface and it's going to probe that location over there. So pretty simple. But the key is to remember that it's just it's shifting. So if this is supposed to be 2 inches and the measurement from here to here was 2 inch 10 thou, but still barely within spec, it's going to shift it up 10,000, so these features are now machined accurately. Okay. So sorry about a little bit of background noise. So we're going to make this our default folder. I'm going to go over to the Model tab. Actually, the 4th operation I don't need to go over because it's essentially the same as the 3rd operation. So we'll show the visibility of the 5th operation here, and then we'll turn off the visibility of the 3rd operation. Okay. Okay, so we got model. We're going to go back to CAM. And let's make this our default. So again, I'm going to hit left click, Shift D. We'll turn on that folder, and I'll show you, kind of tell you what's happening here first. So remember, we still haven't had to manually probe this vise because it's just flipping the part over. We keep that work coordinate in the same position. And then a little story about what's happening here is this is similar to my last job. We made a lot of very, very high tolerance microwave housings. Not much dissimilar than this. So if we machine this on the 1st operation, what would happen is it would go out. We would not machine this pocket here. It would go out, be gold plated, spend a bunch of money doing that, and somebody would work in here and do kind of all kinds of magic for days and days and days. And then once it was working the way they wanted, they'd come back into the machine shop and they would want us to machine this pocket here so they could put a laser welded lid on there. So the step here is super tight toleranced. What they would want is me to come in here and machine off this surface here so it's raw aluminum, and they want me to machine a very tightly toleranced surface there. So we'll show you how I would work through that. So the first thing, the location tolerance is super important too. So the first thing that we would do, so we would do a Y channel. Okay. So we would do a Y channel, so we'd do a new operation, probing, do a work coordinate system, and we're just going to pick these 2 surfaces here. So you can see the default is it thinks it wants to default everything to going over an island. So we have this option here to do a wide channel. It's going to come down here and just bang back and forth and get the center there. So again, it's just shifting the work coordinate system. So where if this isn't where it knows it should be, but in the perfect world of CAD, it shifts it over, so now your new lid is going to be perfectly centered. So after I did that, okay. So after I did that, I would do Control D to duplicate that toolpath because I want to do the same thing. I just want to go left to right through the X. So I'll cancel my selections. I'll click here, and I'll click there, and you can see now I do want to use what they call with a, X channel with an island probing. Now, if I wanted, I could get a little further away from those resonator tubes and go 100 thousandths. Now this clearance is kind of important. I'm confident that my operator is putting this thing in there well within 100 thousandths, so it's basically giving it a clearance. If there was a chip in here or whatever, it's just going to account for it and shift it over to where now you're machining on center of that. So we'll hit OK there, and we'll get a C channel, an X channel probe, and it's going to go up and over the islands. So I'm going to delete those. I'll show you kind of how I walk through this. So we did the Y channel probe, the X channel probe with islands, and I also did, hopefully, yeah. So I also did a Z probe here, and then the next thing I did was machined off that surface. So I could manually lower it in the machine to where it took off the half thou of gold plating, or more realistically, probably 3/10 or something like that. So after I machined it, I probed it again, because the real tight tolerance is the step here. The engineer wants a very tight tolerance between those two. So I probed the Z again, machined the pocket, and then gave it a chamfer. So that's kind of the workflow that I would use our current functionality. If there's any questions about that, I kind of race through it pretty quickly, but I encourage people to bang on it, play with it, and try it. If there's no questions, I have plenty to talk about, but it's going to be more about probing in general, some other advice. Any questions, anybody? Wayne or Jordan, do they have? I'm happy to move on to some other stuff.
Yeah, great work, Tim. We do have a couple of questions. And they're, for one, we're getting a lot of questions, guys, asking if this will be recorded. And, every week we send out the recording to everyone that registers. So absolutely. We're getting a lot of questions about, when this will be released for HSM Works and Fusion. Specifically, I can tell you that since we own the Fusion product, that it'll be released in Fusion first, and then down the road HSM Works. But it's available today in Inventor HSM, which also includes a free seat of Inventor. Really, really helpful for companies that are looking to reduce their operating costs as well. We've got a few requests and a few thank yous, actually, quite a few thank yous saying, thanks a lot, super helpful. We got one who wants to go over the hack section again. We've got
perfect.
Yeah, we've got a couple other ones that want to just go explain the work coordinates as well.
Okay, let's jump into the hack, because this is where I would use this quite a bit. When I was at L3, I used this a lot, and I think Andy from L3 might be on the call today. So I hid it in a folder because I didn't know, didn't have exactly how long I was going to blab about everything else. But so let's go back to model, and we're going to turn on the visibility of that, turn off the visibility of that. So back to the first operation. I'm going to hide, I'm going to hide that stock, hide the visibility of the stock. And let me show you kind of what I would do here. So one of the other things, I don't know if I mentioned it earlier, but my engineer really cares about the ID and OD tolerance of this. It's ±1 or ± whatever seems tight to you. So I'll show you how I would work through that. So I'm going to turn on the Shift-E to make this my default folder. And what I want to do is I want to come in and probe it. And something's important to know. I'm going to pull up my PowerPoint real quick to kind of explain kind of a Haas hack, and then we'll go back to the model. So we'll go over this stuff in a second, and we'll kind of fast forward to this Haas hack. So this is a screenshot from the the VM3 Haas machine that's at L3 Communications right now. So if you go to your operation timers and setup page, I'm really giving you a how-to. So if I race through it and you don't pick it up, get a hold of your HFO, and they can help you work through this. But on the operation timers and setup page, normally you'll see something that says, I believe it says label 1 and label 2, where it says 1 and 2 here. And in the 3 and 4 location, that's where label 1, I think it defaults to 0. But what's happening is this is a macro variable, and we'll go over that. I think we have enough time to go over that in a minute as well. But variable, macro variable 188, so if you come down to probe a bore or a boss or really any feature, it also measures the size, does some math, and all kinds of stuff in the background. But that size is referenced from this macro variable 188. So if you come down and probe bore, it's going to dump that size to 188. It's a temporary dump, but if you change the label like I did at L3 to size 1, in your timers and counters while you're running through memory, you'll see it down here. So it's kind of a neat little hack. We're going to go back to the part now with that explained. So what I would do, and what I did here, is I came in and did a bore probe. So I already showed you how to do that. But then the next thing it is a manual. So if you guys don't know how to do manual operations, I just did a new manual NC. I did a stop. So it's going to pull up an M0. We'll post this out and we'll look at the code in just a minute. So that puts out a stop command. And then honestly, I would just do Control-D and duplicate it, right-click and edit. And then I would change that to a comment command. And so this is kind of in-process inspection. So I called it a hack. We're moving towards the direction of having in-process inspections with you're going to be able to add logic and all kinds of cool stuff. But for now, I did an M0. So after I machined everything, I did an M0, came down, probed this, and this is where I would put a note for my operator. So an M0 is going to pop up, stop the machine. I'm going to put some kind of note like macro variable 188 should be, what's it, 525, and let's do plus or minus 1 or half the hour, whatever your note wants to be to the machinist. So I probed the bore, and I probed the bore, and then I added those two manual operations. So I'll delete those. I would have just duplicated them and then moved down from there. But let's post this out and see how it outputs, and we'll talk about that a little bit. So you can do that. You can see here I probed this. I did a stop. Let me expand this so you can see my note. And then this is going to pop up in the G code. 188 should be 525 plus or minus 2. So the operator is going to see that, and he's going to look at this on the control where it says it's going to say 526, and he's going to say that's fine. And he'll push go again. And in this case, we wanted to measure the bore, or the boss. I don't think I showed you how to do a boss. It's the same. So give me just a second here.
Hey Tim, while you're doing that, just a couple questions that came in I want to make sure you have time for.
Yeah.
Make sure to show how to create a new probe tool type. I think we skipped over that.
How to create a new probe?
Yeah, how to create the actual probe tool.
Okay.
In the library. And then there's quite a few people that would like to see an example of the outputted NC code. So
yeah, so that was what I was getting ready to do just now. And so we'll do that. I just scribbled down new probe type, and we'll circle back to that in just a second here. So let's get back to this. So we're in the hacks. Let's look at the code real quick. So we're going to hit post. So in the latest Haas generic post, the probing functionality is live there. So post this out, and I'll drag it over and explain it. So first thing we did was, tool 25 came up. I hope you guys can see this. It's a little small. Tool 25 came up, and then we're going to fast down, kind of come down beyond this, and, rapids down to this height. And this is where that 6-inch height is nice, because if it rapids to something taller than your probe, if something is set up wrong, it's still going to be safe. So and then it turns on this 9810, and I'm going to show you, I think I have enough time, we're going to show you that Renishaw manual. So I don't think it's important that you really know all the macros, but it's nice, just like with G-code. I've since forgotten a lot of G-code, but I have a good understanding and overview of it. So 9810 is that protected safe mode movement. So from here to here, it's going to move at 200 inches a minute in a protected mode. So the feed rate that's important to talk about is, I know on a Haas SS series machine, 200 inches a minute is what it can move around. I believe that's what it is. It's what it can move around safely and hit something that it didn't mean to and still stop without hurting anything. So the next move, it's going into a 9812 move, which is a just to your blank. It's like a web. It's a dual surface web. And these are the functions in there that I'll show you the manual, and you'll be able to decipher it from there if you want. Then it's moving up in a safe mode, and then it goes into the next tool. I wanted to kind of go down to the bottom to show you how that kind of hack works. So what it would do is it'd finish the program, pull up the probe the bore, and then this M0 would pop up and stop the machine, and then he would see a note right below it that would tell him what that size should be. If it was good, he'd hit OK. It would probe the next thing, stop, and give him another note. So I think we're kind of coming up on time a little bit, so I want to make sure to show you a couple resources. First one, I'll do what Al was asking for. So if we go to the tool library, you can see I defined this probe to be exactly what my OMP40 in my Haas machine is.
Tim, I think you're on the other screen. There we go.
Was there a lag? Probably. Okay.
Well, I thought you're on the other screen with your tool library.
Oh, no. Can you see the tool library?
So we can see it now.
Thank you. So if you look in sample libraries, I think CJ and Al or somebody magically put in a bunch of probes. This one here should be, you should double check it, but it should be a good representation of your OMP40 if that's what you have in a Haas machine. It's probably a good place to start with editing one if you want it as well. So then I wanted to jump back over to this PowerPoint and show you a couple resources. It's kind of what I call good to know stuff. So the Inspection Plus manual, last night, I don't even save this locally. I just go to Google and do a search for inspection, Renishaw Inspection Plus Haas. And this is a really, really good manual to pull up. I think I might have shown that to you at the beginning. If I didn't, a couple pages that are nice to know is if you go to page 21, it's kind of getting started. It explains a lot of stuff. Page 34 is the variables. So this I mentioned earlier. So if you're probing a boss, this is kind of a variable table. The size is output to variable 188. I didn't just know that, I found it here. It's kind of a nice way to see where all your variables are going. So 38 I wanted to show you, so we'll just scroll down to that. And this is protected positioning move. It's that 9810 move I was telling you about. So this is how it works. It's super important to know that if it hits the body of your probe, it's not protected. It's all based on the trigger. So I've seen some people not understand why when they're bounced off their probe head. On that note, if for whatever reason you guys do crash your probe, they do have crash replacements for it, so you don't have to buy a new one. But the last thing I want to do is show you page 59. This is, I tell people you shouldn't have to know G code and macros and all that. But it's always nice to have a good understanding, an overview understanding of what it does. So on page 59, it's the measuring cycles. So this is the cycles that we're using in the background that you're seeing posted out. So 9811 is single surface, so anytime you're probing just one surface, Z, X, or Y. But I encourage you to dig through the whole manual, and you'll see there's a ton of horsepower, a ton of functionality inside the Inspection Plus routines. And I think our goal, and Al can speak to this, but our goal is to add a lot of that functionality in HSM. So last little note is if you saw up on my first slide, Andy from L3, he sent me this picture or posted it on Instagram. Newcastle Racing Service. He posted this, and we use this a lot at L3. It was a pretty small little stylus. It's important to know that when you're changing your stylus, that there's a deflection that you have to be aware of. So if you go to QMark's website, it's the one I've always used. If you go to QMark's website, you can punch in all your stock values, and a little FYI, you need to find out what your probing force is. And on an OMP40 in a Haas machine, it's 50 grams. So last time I checked, it was 50 grams. So if you're changing from your stock stylus to your, to something else, understand how much the deflection difference is, so you know what you're doing there. I know a lot of you guys have not seen a Renishaw probe in action outside of just manually jogging it around, so I thought I would show you guys this video. CJ's one of our team members. He and Angelo, a new team member of ours, are at our Pier 9 workshop, which is an amazing little workshop in San Francisco. and they're banging on the software now pretty hard, so you should see functionality, adding pretty quick and often. So, is there any other questions that I missed?
Let's take a look here. And on the Pier 9 point real quick, if anyone's ever in San Francisco, please reach out to myself or anyone else on the team, any Autodesk contact you might have. We can get you set up with a tour. We do need to get those scheduled in advance, and we need to understand how many people you want to bring, but that's why we have that facility, is so that you guys can come and actually see the technology as well. Same right out on the East Coast. So if you're ever in Boston, we've got a brand new build space out there that's being developed, and we're going to have a really big footprint for CNC machining out there as well. It's in the Seaport District of Boston. It's an incredible space, so definitely let us know and take advantage of that as well. Taking a look at the questions here, they want to know in the hack if the bore is out of tolerance, how is that info outputted back to the operator? And that's from Derek Goodwin, actually one of our partners.
Yeah, so Derek's one of our partner resellers. So right now, like I said, it's a hack, and I want to show it kind of last so people understood. The value that you're going to be given is just the measurement that it took. So there is, you can read in the manual about how to then add logic or intelligence. Derek's from Selway, your guys over there, your application guys can, they do that all day. We just got Angelo's one of our team members. He's made a good living doing that, as well as I. But right now in our user interface, there's no way to add intelligence. I think that's the right term for it, but or logic. But it's something you can kind of hack into it, or just keep an eye out for what we're adding to functionality, and it'll be added there. Hopefully, right now.
Unmute myself.
I'm not sure.
Yeah. So what we have today, effectively, it's going to be very similar probing operations, the same type of probing you're doing, but there's many things you might want to do if you probe. If you probe a feature, you really need to start to get into some logic to say, if it's within this tolerance, then go on to this next operation. If it's within this tolerance, update my tool offset and remachine it. If it's in this other tolerance, then the part's scrap and stop doing anything. So we do start to cross the line into needing some logic around what we do based on what's probed, but we're very aware of it, and when we are working towards getting the product there.
Yeah, I'll add to that if you see the probe operation, it wasn't called WCS probing for no reason. That kind of leaves us open to then add other probe names for achieving different functionality.
Tim, everybody loved your demo so well. There's a lot of people who'd like to get their hands on this inventor file, so we will definitely find a way of getting this to everybody.
Yeah, I'm happy to share. Happy to share. So I think honestly that's a kind of race through it. I hope everybody was able to keep up. I hope everybody will be able to see the recording soon if you missed something. It's a ton of information. There's a ton of horsepower in probing. I think our priority initially is to get a good foundation and spread across all our HSM products. I know a couple people, not a couple people, but I know a lot of people on my Instagram and different places are asking when it's going to spread to the other products. Do you have any comments on that, Al? Not to put you on the spot.
Fine. So there's a couple things that I'll hit on for the HSM Works users. All of the toolpath technology, I think from a kernel level, very easily shows up across all three products. Things like probing are very graphical and not really that big of a toolpath problem. So it takes a little bit more work to make it happen in HSM Works from just having it happen in Fusion and in Inventor. So in Fusion will be in shortly. It's actually in beta mode in Fusion now. I can share that with some of you how to access beta mode. I just caution you to not use beta mode in Fusion on a regular basis. So we're very, very close to it in Fusion, probably closer to the end of the year, having it in HSM works, and then in Inventure how we can dynamically move the planes up and down graphically in the user interface. Those sorts of things are difficult for us to do in SolidWorks, so we do have to come up with a slightly different user interface for, around how we can make it work in HSM Works. Any of you are happy to reach out to me. Again, I'm active in the forums and socially also, so feel free to reach out for those of you that don't know product manager.
And same here, same here. So we're happy to ask any question or answer any questions, and hopefully get some people probing, using their work probing. I think there's a ton of opportunity for people to increase their productivity with this.
That's awesome. And, you know, as we're putting these together, next week we're going to do a deep dive into our adaptive clearing technology and really get into the nuts and bolts of that technology. My ask to everybody involved, if you found any value in the HSM Hangout, please shout it out, let us know, and feel free to invite a friend. We're trying to get everybody that joined us this week to invite a +1 for next week and see if we can double down the number of people that join us for these weekly HSM Hangouts. And then if there's something you need to see that you want us to cover, let us know, and we'll get it on the schedule. So with that, Tim?
One more quick, my apologies. There's a number of people asking about which post-processors this will be available for. It's working in the HOS now with Renishaw cycles, so you could copy and paste that into another machine if you're using Renishaw. The other thing is, for those that don't know, we have an idea station that works quite well for post-processors, and that's how the team prioritizes the work for updating stock post-processors. So if there's a number of you that want to try probing on a specific machine, that'll help us identify which ones to work through first. So I'm posting a note with a link to the idea station. I just ask that you guys, through the idea station, let us know which machines are a priority to get this added to.
Perfect. Awesome. And Al, thanks so much for joining us, too. I know that you're a busy guy. You're in charge of developing the product, the HSM product line, so it's awesome that you were able to join us today. And Tim, you know, thank you so much. I can't wait for you to come back and join us on future webinars.
Awesome. Thank you. One last thing I would say, we are in Northern California. We're starting a meetup. I'm calling it the NorCal Machinist Geek meetup. So we should be sending some emails out. There'll be a link in my bio on Instagram. We're trying to build a community and just share knowledge and be awesome. So if you're in Northern California or near Sacramento at all, we encourage you to come out and check it out. We've got a really cool community here, and we're building it one group at a time.
That's great. Yeah, and that event will most likely be catered by Autodesk as well. So not only will you get to you know, learn a lot about the technology, you'll get to most likely get some nice snacks as well and hang out with the team. So thanks again, everybody. We'll see you next week when we cover adaptive clearing in detail. And as always, if you have any questions, hit up Tim, hit up Al, hit up myself, get involved with the forum. If you have any awesome ideas that you want to see in the product, we have an idea station where you can upvote those ideas, and we put the best ones in the product. And then, as always, Autodesk software, it's free for students and educators, so just Google Autodesk Education, and you can also use the Autodesk Knowledge Network as an additional resource to self-educate, in addition to the forums and all the other great resources and YouTube videos that are out there. So see everybody next week, and don't forget to invite a friend. Thank you so much.